Here we are again, playing with Code Sculptor. So the last time we figured out how to get the ball to wrap around the screen. And now we want to figure out how we can tell if two balls are touching. So this is a wonderful time to be alive because you guys have the internet and the internet knows everything. And if you Google like circles colliding or circle collision and look up images, this is one of the images I found, and it says if distance between centers, so here's the center of the big circle, here's the center of the little circle, if the distance between the centers is less than circle 1's radius, here's the radius of circle 1, so the radius is the line from the center of the circle to the edge, plus circle 2's radius. The radius of circle 2 is right here, right? So if the distance from this center to this center is less than this distance here plus this distance here, then they're colliding. Okay? Pretty cool, right? And actually, I clicked back to the website where this came from, and there's this whole it's a Flash thing, but it's a whole article on elastic collision detection between entities. It says in Flash, but you can use the basic logic for to do something in Python that looks like that if you wanted to play around with that. But I'm since that's already there for you to look at, I'm going to go back to our original thing here, and I just want to make a method to tell if one ball is touching another ball. Okay, so I am going to add on a method here. Oh, it looks like I got an extra space. I'm just going to delete that. I'm going to define define a method called isTouching, and I'm going to look at myself, and I'm going to look at the other ball, and I am going to I want to return true if the radius of one is the same as the radius of the other. But how do I know what the radius is? I could just I'm going to put pass for a second here. I could just assume that the radius is going to be what do I draw it as? I think 20, right? Yeah, I could just assume it's going to be 20 here. But you know what would be more interesting is if I actually had a radius state variable right here. So if I said, so I'm going to do a little refactoring again. Self radius equals 20. I'll just set it to 20 as the default. And then I want to make this be self.radius. Okay, so again, that's a code change that didn't change any behavior. Even though I added this little dummy method here, that's not going to do anything because I'm not calling it anywhere. So the only real thing I need to test out is to make sure that I did this change with the self radius correctly. So my circle should still have like a radius of 20. So yeah, it looks like it's the same size still. If I do it again, is it always having a? It looks like the. Oh, there it goes. Yeah. So it's because it's randomly picking the dy and dx. It's gonna every once in a while it's gonna be vertical, but it should keep changing. Okay, so that's cool. So that looks like I didn't break anything with the self radius. So now in this isTouching, I can look at the radius of this circle and the radius of that circle, right? So let's say, well, I need to return something, and I need to what I need to return, what I want here is I want to return either a true or a false. So true if they're touching and false if they're not touching. Okay, so we need to look at the distance between the two. So for right now, I don't have a distance formula built in here, right? But I'm just going to pretend like I have a distance method. I'll say distance. If my distance to the other circle is less than the sum of my radius plus the other guy's radius. So see here, if the other is another ball, right? If the other is another ball, then it's going to also have a radius associated with it. So I can say my radius, and so basically this is saying ask who, if you're in logo in microworlds talk, right? Who is me, is the ball that's actually invoking this method. So if my radius plus the other, so other is another ball, so you can also get the variable from some other object, right? By putting other dot, or whatever the name of the other object is, dot variable name. If I add those two together and they're bigger than the distance between the two objects, then this is going to, or if they're less, then this is going to be true. So if the sum of the two radii, if you add these two radii together and they come out to be more than the total distance here, then that means that they're touching, right? Or they might be overlapping some, or they'd be touching. If this isn't clear, again, I suggest just like go and Google. How did I do it? I think circle collisions, and just check out the images. So here's an example where if you look at, here's the center of this circle. Maybe I can make it bigger. So here's the center of this circle, here's the center of that circle. So the distance from here to here is less than the sum of this radius plus this radius. Okay, and like I said, there's a bunch of images to look at and different sites that explain it and stuff like that. So well, here's an interesting one too, talking about because the other thing we're going to have to do is calculate the distance, right? So actually, so what we've done so far, what have we done so far? So far we've figured out this is how we know that they're touching, but we don't have this distance method, right? So let's oops, what am I doing? Def distance self. Okay, so this is going to return a number that's going to be, how far away is the center of one circle to the center of the other. Okay, so maybe let's just try this as an experiment. Let's Google distance between 2 points, and actually this is kind of a nice picture of that, but I'm going to just see anyway, and I'm going to look at images, see what kind of images we have. So I want to pick out a picture with a triangle in it, because I think that makes it kind of clear. Actually, maybe this one is a little bit better. So well, I'm going to look at this one first. Let's see if you can see it. So there are going to be, and there's a x value, so we have this point P and this point Q, right? So this is the center of one circle and this is the center of the other circle, and we want to get this distance. So this point is going to have some x value, and here we're just calling it x1, and some y value, y1, right? So this distance from here to here, this is going to be x2 minus x1, right? And this distance here is going to be y2 minus y1, except in our picture that's kind of flipped around. So I think what I'll do, actually, since I'm kind of running out of time anyway, I think I'm going to draw a picture, because these regular Cartesian coordinates don't work that well when our r0, 0 is up here and we go this way. We don't start somewhere down here and go up in the y direction. So I'm going to have to change this, do a slightly different picture for us, and we'll tackle distance between the centers in the next video.